Actually, in the definite integral, various problems seems to be very complicated. We can solve these problems with the help of the properties very quickly, very accurately, but for that we just need to remember these 7 properties. Now I want to tell you what are these properties. Properties of the definite integral are: first one, the first property is if integration is from a to b fx dx, then it is equals to a to b fy dy. Meaning by change of variable will not change the result, which I can show you. Suppose it is 1 to 2 x dx. Then what's the answer? X square upon 2 1 to 2. That is 2 square 4 upon 2 2 minus half. The result is 3 by 2. But in case in place of x you write y dy, then the answer will be y square upon 2 1 to 2 and answer will be again 3 by 2. So here the purpose to explain you the first property is that change of variable, change of function will not change the result in the definite integral. Here the question was in x, final answer was 3 by 2. Here the question is in y, final answer is also 3 by 2. Anyhow, now I want to tell you that is if a to b fx dx is same if limits are reversed, lower limit a made upper limit and upper one taken lower, then here answer comes negative of fx. If I explain you this property with the help of one example, suppose we have sin x from 0 to pi by 4. What is the answer of the sin x dx 0 to pi by 4? It is equals to cos x 0 to pi by 4, which we can say cos of pi by 4 minus cos of 0. Cos pi by 4 is 1 by root 2 and cos 0 is 1. This become 1 by root 2 minus 1. If these limits are reversed like this, pi by 4 made the lower limit, 0 made the upper limit, then the sin x dx, if limits are reversed, then the answer must be with a negative sign. So minus of derivative of sin x is cos x. Limits are from pi by 4. Here the answer we have taken 1 by root 2 minus 1. Its answer is 1 by root 2 minus 1. And answer in case when limits are reversed can be calculated as by taking minus of cos x of pi by 4 to 0. So upper limit cos x, cos 0 is 1. So this will be minus of 1. Lower limit cos of pi by 4, 45, 1 by root 2, minus is out. So we can say it is what? Minus 1 plus 1 by root 2. So clearly this answer and this answer are equal. What we have done, if limits are reversed, then the negative sign will reflect outside. This is the explanation of this property. If limits are interchanged, then what impact comes on the problem. Next, a to b fx dx is a to c fx dx plus c to b fx dx. Meaning, it's very simple. If I explain you here, 1 to 4 and question is e to the power x dx. This can be breaked as 1 to 2 e to power x dx, then 2 to 3 e to the power x dx, then 3 to 4 e to the power x dx. So ultimately we can break the limits in as many parts as it is possible from lower to upper in between, but the final answer will remain same. So a to b fx dx is equals to a to c fx dx plus, then here upper was c to b fx dx, where thing to be note is c lies between a and b. Now with the help of one example I will explain you the third property. A to b fx dx is equals to a to b f of a plus b minus x dx. We can say it is, suppose a problem is here 1 2 3 x dx. The answer of this part will be same as a to b, that is 1 2 3, f of a plus b, that is 1 plus 3 4 minus x dx. Answer of this part and this both will be same. You can verify. It is x square upon 2, it is the lower limit 1 and upper is 3, and is equals to, this is 4x minus x square upon 2, 1 2 3. When we will evaluate, we will get the answer in both the cases as 9 by 2 minus 1 by 2. Then this answer will also be same. We can use this property. And the last property, if it is 0 to a fx dx, then it is 0 to a f of a minus x dx. This is nothing. In place of the lower limit 0 is put, and in place of upper limit b. So if a question is 0 to 5, suppose it is cos x dx, you can say it is 0 to 5, or as it is cos, you can take pi by 4, some trigonometric value, and 0 to pi by 4 cos x dx can be written as 0 to pi by 4 cos of a minus x, that is pi by 4 minus x dx. Now the sixth property, that is 0 to 2a fx dx, can be written as twice of 0 to a fx dx if f of 2a minus x is fx. Whenever 0 to 2a fx dx you want to write twice of 0 to a fx dx, you need to verify whether f of 2a minus x is equals to fx or not, and 0 if f of 2a minus x is equals to minus of fx. Then the last property, property number 7, if limits are from minus a to a, say for example minus pi by 2 to plus pi by 2, minus 10 to plus 10 fx dx, then it is twice of 0 to a fx dx if function is even, and 0 if function is odd. So whenever you will use these two properties, you have to be very attentive. If 0 to 2a fx dx, it has two values, it may have 0 if f of 2a minus x is minus fx, and twice of 0 to 2a fx if it is f of 2a minus x is equals to fx. Similarly, minus a to a fx dx has the two values, 0 to a is twice of 0 to a fx dx if fx is even, and 0 if fx is odd function.